All right, guys, we're finishing up the note sheet from yesterday. So note sheet from yesterday. I believe this is where we stopped yesterday. So we're using the properties of logarithms to be able to evaluate each one of these here. Now they told us that log base 3 of 4 is approximately 1.262, and log base 3 of 5 is approximately 1.465. And we're going to use these to be able to evaluate each one of these here. Now the first one, log base 3 of 4/5, well, we can rewrite this using our quotient property as log base 3 of 4 minus log base 3 of 5. Now log base 3 of 4 is approximately 1.626, and log base 3 of 5 is approximately 1.465. And now at this point here, we can just subtract these two from each other. Three, 0. We should get negative 0.230. At this point here, we could plug that subtraction in the calculator, let it do it for us, and it'd give us our answer. Questions on the first one here. Now, if we look at the next one, log base 3 of 20. Now, using 4 and 5, well, we can rewrite this as log base 3 of 4 times 5. Because as we're rewriting this, we're either going to rewrite it as a product, a quotient, or a power. Now, according to our product property, we could rewrite this as log base 3 of 4 plus log base 3 of 5. Now, log base 3 of 4, as we just said, is 1.262. Plus our log base 3 of 5, so that's going to be 1.465. And the last thing we have to do is add these two together. 7, 2, carry the 1, 4, 5, 6, 7. 1, 1 gives us 2.727. And our last one, log base 3 of 25. Well, 25 is the same as 5 squared. 5 times 5. Now our power property says we can move the 2 to the front, giving us 2 times log base 3 of 5. And from what it told us, log base 3 of 5 is 1.465. So all we have to do now is multiply this by 2. 1, 3. And we get 2.930. Questions on these here? Now the last thing we're going to look at with this here is the change of base. Change of base lets us change the base of any logarithm. Now the reason this is nice is because the 30xs here, this log, the log button is in base 10. So if I could rewrite the log or change the log to base 10, we can use this here. Now according to the change of base, log base C of A is equal to log base B of A over log base B of C. Or for us, we can just change it to base 10, telling us that log base B of A is equal to log of A over log of B in common logs. And the same thing is true for natural logs. We can also write it as a natural log. So we look at this here, log base 3 of 8. If we're going to write this using the change of base, or rewrite this using the change of base, we'd have log of what's inside, so log of 8 over log of its base, which would be log of 3. And that's the change of base. And the reason this is nice is because now we can grab the yellow calculator, the 30xs, hit the fractions key, and say log of 8 over log of 3. And so that's it. That's the answer, 1.892789, or 1.8928. And that's it, because we could do this in the graphing calculator. We can do our math, go to log base 3 of 8, and it would give us the exact same thing. But with a lot of ways, having the change of base helps us be able to get through and solve these a little bit quicker, a little bit nicer. Now the next one that we have is log base 7 of 11 here. So if we rewrote this with the change of base, this would be what? Log of 11 over log of 7. Log of 11 over log of 7. Is going to be 1.2323. Approximately. Questions on this here? Now, what's interesting, we can also do this with natural logs. Now, the way it works with natural logs is the same way as our common logs. So on top, we'd have the natural log of what? 24 over the natural log of 6. Natural log of 24 over the natural log of 6, and we get 1.7737. Now, if we looked at it with log of 24 over log of 6, we get 1.7737. That is the exact same value. And the reason this works is just because, by definition, log base C of A, according to change of base, is equal to log of B of A over log of B of C. And for what we've been using, we've just been setting that base, the new base here, to be 10. For this here with the natural logs, all we did is instead of having this base be B, we said that base was E. Well, E, whenever the base is E, we don't talk about it as logs. We talk about it as natural logs. So we just set the base as E, which is going to be a natural log. So it works the same way. So log base 2 of 19 would be the natural log of 19 over the natural log of 2. So I guess it's going to be close to 4. Natural log of 19, natural log of 2, 4.2479. Questions on this here? Question on anything we've done so far? That's it.